So, hello guys, welcome back to my channel. I'm Shivam and I make content related to coding. Today we'll be solving a problem which the very first problem of a bi-weekly contest 174, which was today in 17th of Jan. Okay, and this is lead code problem number 3890, which is best reachable tower. Okay, so let's see the description of this problem and look at this input, and then what we will be writing down, how we will be solving process, and then what we need to give as output. Okay, so in input we will be given with these two vectors plus an integer, and then we need to solve something, and then there is an output which will be uh, like which consists of two numbers x and y, where these particular x and y represents a particular point in a coordinate. Okay, so let's go on to the description of this problem. What I would want you guys is to read this description thoroughly and understand what the problem asks, what are the given inputs of this problem, and what are the given output of this problem. Okay, I'll just be explaining in brief. I'll just be explaining in brief, and hope you understand whatever I'm talking about. Let me erase this. Now my whiteboard is totally clean. So these two particular vectors represent a point in a coordinate in a 2D graph. Okay, so let me just plot a few points in this graph. Let's say 1 comma 1. We are at this index, and let me just point it away from every other point so that it is clear to us where we actually are. Now let's look at this particular index 1 comma 2, and it has quality of 5. Then we have another point which is 2 comma 7. No, it's 2 comma 1, which is over here, and it has a quality of 7. Then we have another point which is 3 comma 1, and it has a quality of 9. Okay, so the first 2 points in this particular vector is x coordinate and y coordinate, and the third point in this vector is a number which denotes quantity. Okay, and at the end of the process we will have to return a particular uh, coordinate x and y, which uh, okay, so at the end we will be returning a particular x and y coordinate uh, with these following constraints. Okay, constraints. So what we need to do is we first of all we need to find reachable coordinates according to question. And as you can see, the definition of a tower is reachable if its Manhattan distance from center is less than or equal to the radius. So coordinate is reachable only if its Manhattan distance is smaller than or equal to particular r. At this case r is 2. Okay, and we need to find coordinates such reachable coordinates whose quality is maximum. Okay, so we just need to return one index whose quality is maximum. That is what the problem is essentially asking, right? And if the way we calculate Manhattan distance in any problem, for say, is like x1 minus x2, we are taking mod actually. we are actually taking mod over here, then y1 minus y2. Okay, so we are having this equation represents Manhattan distance between 2 points. Manhattan distance is yet another way to calculate the distances between 2 points in a coordinate. And yeah, so we have two ways. First is our Euclidean formula, and then we have Manhattan distance as wait a minute. Yeah, then the second way through which we calculate distance between 2 points is our Manhattan distance, and it is this equation that we will be using to calculate the distances between any 2 points in the coordinates. Okay, so this is fine over here. Now, how we will be returning a particular output which is reachable plus has the highest quality. This is what we need to return over here. Now if we I'm teaching you like a rote learner, right? Well, this was the very first day when I solved this problem, so you cannot expect much from me right now because everything is in my head. So the thing over here is that the very first thing that I can do is to calculate Manhattan distance for all points relative to center. I have a pretty slow laptop. Okay, so we will be looking at distances from the center. Well, if it is taking time for me to adjust to tools, let me just write my code and I'll be explaining you along the way. So first of all, we will be calculating Manhattan distance for each and every point relative to our center, and when we find that, and when we look for a particular coordinate which is reachable, when we have a particular coordinate which is reachable, then we have let's say a global variable which is max quality. Okay, which is max quality, and this max quality will be updated if our current quality is greater than our max quality. And whenever this condition will be there, then we will just store these particular two x1 and y1 for every current index into answer. Okay, now there's one more thing that we need to keep in mind while solving this problem is this particular line. Okay, the Manhattan distance between 2 points x1 and y1 and x2 and y2 is this, and a, a coordinate x1 and y1 is lexicographically smaller than x2 and y2 if x1 is smaller than x2, or x1 is exactly equals to x2 and y1 is smaller than y2. Okay, so this line is pretty important because whenever we are having such points, let's say we are at this particular index 0 comma 0, and there are two coordinates whose distance from the center is reachable. Okay, these both of these 2 points are reachable, and one and point A has quality q1 and point B has quality q2. Let's say both of these two qualities Let's say both of these two qualities, q1 and q2, are exactly equal. Okay, if this is the case, then which one of the coordinates will we have to return? The coordinate which is lexicographically smaller. If x1 is let's say smaller than x2, then we will be returning x1 and y1. Okay, or if x1 and y2 are both equal, no, x1 and x2 are both equal. Let me erase. There's few technical glitches that will come along the way, and that is understandable right now. Okay, so if x1 and x2 are exactly equal, this is the second condition. If x1 and x2 are exactly equal, then we will check the other coordinate, which is y1 and y2. If y1 is smaller than y2, then we can say that we will be returning x1 and y1. Otherwise, we will be returning the other coordinates, which are x2 and y2. Okay, so this is all the theory regarding this problem, and now all there is to do is to just implement this problem, nothing else. Okay, so now I'll be implementing this problem. Let's see what we can do over here. First, as I've already told you, we can take int as then we can take then we can take a vector which will be our output. It will consist of only two elements, and initially we will be in a default case where no element is reachable, then we will be return -1 as when no point is reachable. Okay, so now what we will do is we will iterate throughout the vector towers. What we will be doing is we will be calculating Manhattan distance, which is given by mod of x1 minus y1. Center of x1 is our center, which is x1 of 0 minus towers of I. This is x2 minus abs of okay, so this is our distance between 2 points. Now if now we will also have to take quality, which is towers of I and at the second index. This is fine. We will also have to take we will initialize this max quality. Now our code will revolve around quality, if our particular quality at if our current quality is greater than max quality, then we will update our answer. Then our x coordinate will be set to towers of I comma 0, and at last we will update our max quality to quality. In a case where quality is exactly equals to max quality, when both of these qualities are exactly equal, when max quality is exactly equals to your particular current quality, then I have already told you what we will be doing is we will be checking two conditions. If your particular x1 is smaller than x2, or if our particular x1 is exactly equals to x2, such conditions we will be checking for these all conditions. Okay, so if your particular our previous answer of 0, or our particular answer is exactly equals to, otherwise if y1 is smaller than y2, right? If this is true, that the previous indexes are equal, the max qualities indexes are equal, uh, then we will just continue. Else we will copy this particular part. Let me check uh, the solution. We can have another check so that our time complexity is decreased a bit. We can decrease our time complexity through this. If our quality is smaller than max quality, then continue. Yes, I think my code should work. Okay, so there are some error within my code. Yeah, so we have actually done we are logically wrong over here. if our quality is greater than our max quality, as well as and our particular distance is smaller than radius. If it is reachable and the quality is greater than our max quality, only then we will update our coordinates. Hmm, Let me check where the problem really is. We don't need to update our max quantity over here. Hmm, is for reachable. No, 4 comma 4 is not reachable. Hmm, yes, so yes, again we are doing some very silly mistakes. Our Manhattan distance is not calculated by subtracting the these two entities. Instead, we just need to add these two entities, x1 minus x2 plus y1 minus y2. Let's sum this problem and see if our solution is correct. Yes, it is correct, efficient, and it's fine. Okay, so this was it, guys. See you in another video in another time. Like, I will try to post as frequently as possible. So, log out.